So let's take three cases of very simple absolute value kind of deals. If we say the absolute value of some variable x is equal to 5, what does it mean? It means that whatever is inside of there, it means that x is 5 units from 0. It means that whatever x is, once I take its absolute value, it's 5 units away from 0. So there's only two numbers that make sense for that, for this particular example. And we all know that this means that x can be 5, because if we put the 5 in there, the absolute value is 5. Or x can also be equal to -5, because if we stick -5 in here and take its absolute value, we also get 5. So another way to rephrase everything that we have on the board is that the number 5 over here is 5 distance units away from 0. And the number -5, which is over here, is also 5 distance units away from 0. So if we were going to plot this, if we were going to plot the answer to this, this is not an inequality, this is an equation. The two solutions of 5 and -5 would be what? It'd be a dot over here at -5, and it'd be a dot over here at +5, right? And this is the only 2 points that satisfy this equation, because we put one of them in here, we get 5. We'll put the other one in here, we also get 5. But more fundamentally, I want you to remember that when you see an absolute value, it means that whatever's on the inside is 5 units away from 0. 5 units away from 0 is what this one is. 5 units away from 0 is what this one is. The reason I want that to be in the back of your head is because it will help you when we discuss the next part. Let's say we had another guy, but this is not an equation anymore. It's a very simple inequality that involves absolute value. Let's say the absolute value of x is greater than 3. What does this mean? It means that now we're not going to be getting just 2 points back. We're going to be getting a range of values, or multiple, just like we're always doing all these absolute value problems. We always get shaded areas on the number line. But what we're saying is, whatever the answers for x are, the absolute value of them, which just means their distance from 0, must be greater than 3. So the set of numbers is what we're saying x is going to be, has got to be 3 units or more greater from 0, bigger from 0. So let me write that out real quick. So what this basically means for each of these, we're going to write a couple cases here. We say x is more than 3 units from 0. So when you rephrase it in terms of English like that, then it's a lot easier to find out what the answer is. When we say it's more than 3 units from 0, what we're saying is that x has got to be greater than 3. That would be 3 units away from 0 or more. Or x can be, this is the part where you got to start paying attention, less than -3. Either one of these means that the set of values of x will be bigger than 3 units away from 0. And to see why this is the case, let's plot both of these on the number line. What is x greater than 3? Well, x greater than 3 would be open circle at 3, and it would be all the values to the right of this. X greater than 3 would be 4, 5, 6, 7, 8, and all the little decimals in between. But x less than -3 would be an open circle at -3 and all of the values to the left, like this. All the values to the left. All right? So because of that, remember what the original absolute value is saying is whatever x is, it has to be, because its absolute value is here, it has to be more than 3 distance units away from 0. That's what it's basically saying. So we translate that to this graph. This is, of course, more than 3 distance units from 0. This is more than 3 distance units from 0, and so on and so on and so on. But when you look at the negative side, this -4 is more than 3 distance units from 0, and the -5 is more than, and the -6 is more than, and so on. So when you see an absolute value of something bigger than a number, you need to mentally think of this on the number line. It's going to be bigger than 3 units away from 0. So when you see a greater than sign with an absolute value bigger than some number, then it means on the number line it's going to be a shaded region on the number line larger, extending on to positive and negative infinity away from 2 points. Because all of the points here that make up x have to be 3 distance units or more bigger away from 0. All right, now let's put the third case on the line, and then we'll be able to compare them and make it much, much simpler. The third case would be if you had the absolute value of x less than a number, and let's just pick a different number to make it easy. less than 2. What does this mean in English? It means, remember, absolute value means distance from 0. It means the set of points x have to have a distance from 0 that's less than 2 units away. So let's write that down before you go any farther. What it means is x, the set of points x, is less than 2 units from what? Always from 0, right? So what that means in terms of, writing it out like we did here, it basically means that x can be less than 2, but x also has to be greater than -2. I'm doing a translation. It's like going from Russian to English or French to Spanish or something. You have the absolute value problem, but you have to, in your mind, understand what it's saying so that you translate it into these two separate equations, because you already know how to solve these equations and how to plot them. We've been doing that before. So the only step here with the absolute value inequalities is taking this and translating it into English. So let's see why this is the case. X is less than 2 means I put an open circle here at 2, and it's going to be the numbers less than. And x is greater than -2 means I have to put an open circle here. So it has to be greater than -2 and less than 2. So it's this line segment, right? So now you see what it means. It's when you have an and, it's a segment on the number line, just like before. When you have an or, it's going both directions from some points, just like before. The only new part of the wrinkle is that you need to start to remember that when you see an absolute value of x or some expression of x greater than a number, it's basically an or type of problem. And whenever you see an absolute value of x less than a number, you need to think of it as distance from 0 has to be less than 2 units, so it has to be a region symmetric, with 0 in the center, that's 2 units to the left, 2 units to the right, because that's what that means. So it's a little hard in the beginning to read those problems and say, oh yeah, that's going to be this. But as time goes on, you will start to realize when you see an absolute value less than some number, it's going to be a segment on the number line, and means it's going to be an and kind of deal. And whenever you see absolute value greater than a number, it's going to be extending on to positive and negative infinity, both directions, as the or problems have been doing in the past. So I think the best way to proceed is I want you to try to remember these cases. But the best way to proceed is let's go ahead and do a few problems and graph them, and you'll get some experience as we go on. So probably the easiest one we can do will look similar to this one, right? Where we had an absolute value of something equal to a number. So let's do one like that really quickly and see what we get. Absolute value of 3x minus 2 equals 8. Now what this means is that whatever goes in this absolute value here, whatever this expression is, I have no idea what it is because it has a variable, but whatever it is, whatever is inside of here can either be a positive 8 or it can be a negative 8, because once I take its absolute value, it's going to give me 8. So you always are going to kind of get two little equations out of this. What you're saying is 3x minus 2 can definitely be equal to 8. Of course it can. Or it can also be equal to negative 8. Why? Because if I replace this with 8 and take its absolute value, I'll get 8. If I take and replace this guy with a negative 8, I will take its absolute value and I'll still get 8. So I can make it equal to positive or negative 8, and then I just solve them separately. So moving the 2 to the other side, 3x equals, when I add 2 to both sides, I get 10. And when I get x by itself, it'll be 10/3, just dividing both sides by 3. So this, or let's solve this side. Adding 2 over here, I'll get 3x equals, what is negative 8 plus 2? You'll get negative 6 on the right-hand side. If I divide by 3, I will get negative 6/3. So that means that x is going to be equal to negative 2. So what I figured out is that there's an or here between these guys, because this inside of this can be either plus 8 or minus 8, so the or kind of ripples down to the bottom. So what we're basically saying is that this absolute value equation has two different answers. One of the answers is if we put a negative 2 in there, and the other answer is 10/3. So if we plot them on the number line, what we're going to get is we're going to have a dot at negative 2, and then we'll have another dot at 10/3, which is basically 3.33. If you divide that out, it's 3.33, which would be, here's 3, here's 4, so it's basically going to be somewhere around here. And there's 2 points, only 2 points. There's no range of values because there's an equal sign here instead of an inequality. And you can always check yourself. Put -2 in here. What do you get? 3 times -2, -6, minus 2, -8. Take its absolute value, you get an 8. Stick a 10 in here. 3 times 10/3, the 3's will cancel, you'll get 10. Minus 2 will give you 8. Take its absolute value, that'll give you the 8. That's why you have 2 answers, because the whole entire thing on the inside can either equal 8 or it can equal -8. Both are going to give you the same exact answer. All right, so typically when we do these things, we kind of introduce by showing some simpler problems like this one. But typically what you'll have is inequalities greater than something or less than something, and then you'll have to translate it, as I said, using one of these rules into an and or an or kind of compound inequality, and then solve it the same way as before. So as we solve the next problem, keep in mind, if you see the absolute value of something bigger than a number, it means it has to be that many distance units or more away from 0. So you're going to have shaded regions going away from the origin. And if you have an absolute value of something less than a number, it means you're going to have a shaded segment that's centered around the origin. So let's go and see that in the next problem. So what we're going to have for the next problem is going to be absolute value of 3 minus 2x less than 5. So immediately you need to try to categorize this and try to figure out what it's going to look like. Now I know that this doesn't say x, it says 3 minus 2x, but still it's some expression of x inside of this and it's less than a number. So if you can think in your mind, what we just said to remind ourselves is this is 0. If this were x, it would be, whatever this is, has to be less than 5 distance units from the origin. So if that's 5 and that's -5, then 5 distance units plus or minus 5 distance units from the origin means it's going to be a segmented, line segment shaded there, which means it's going to be an and kind of deal. If this were flipped the other direction, greater than, then it would be an or, and it would be shaded both directions out to plus and minus infinity. But what you're saying is what's in here has to be 5 distance units away or smaller from the origin. So that's exactly what we have shaded here. So let's go and solve the rest of it. Now that you kind of put it into words, now you can rewrite it and say we have 2 inequalities. 3 minus 2x, it is going to be less than 5, okay? But also, I guess I'll go down over here. 3 minus 2x can be greater than -5. Look at what I've written here. It can be less than 5, but if I join them with an and, it can be less than 5, but greater than -5. So this quantity can be greater than -5 and less than 5 at the same time, forming a segment there. I've translated this to English, and now the problem becomes exactly what we've done in the last section, just solving those again and again because we've done a lot of them. So let's move the 3 to the other side. We'll get -2x less than. Subtract 3, we'll get 2. And then x, now we're dividing by -2, so we'll have to flip the direction of this, 2 over -2, so x will be greater than -1. That's going to be 1/2 of the answer. The other half of the answer will be over here. Move the 3 over here by subtraction. -2x greater than, what is -5 minus 3? -5 minus 3 will be -8, right? Now we get x by himself. But we divide by -2, so we have to flip the direction of our arrow. -8 divided by -2, so x will be less than +4. And since there's an and here, this is joined by an and as well. Both of them have to be true in order to form a line segment like that. And since they both have to be true, we can stick and rewrite it again in our other notation. X, we'll put our less than signs in both places. X is greater than -1. X is less than 4. So this is what you would circle on your test. X is greater than -1 and at the same time less than 4. But if we come over here, we can say less than -1, or I should say greater than -1, at the same time less than 4 means it's a segment that extends between these two, So it's greater than -1 at the same time being less than 4. Greater than -1, less than 4. So it forms this line segment with 2 open ends at the end. So literally everything in this section boils down to you being able to translate the problem from what we had before into 2 inequalities, which we already know how to solve from the last section. All right, let's do this next one. This one's pretty good, I think, to illustrate a point. 2x minus 5, absolute value, equals 0. Now, we had a similar set of problems. We said when we had an absolute value equal to a number, it could say the inside is equal to 5 or negative 5. We actually did one here. We said the inside could be equal to 8 or the inside could be equal to negative 8. But this is why I wanted to do this problem. Now we have an absolute value equal to 0. Well, there really is no such thing as negative 0 and positive 0. 0 is right in the middle. So really, there's only one equation here. When you have an absolute value equal to 0, there's not two different things to pull out of it. Basically, there's only one. 2x minus 5 can be equal to 0. You can't have a negative 0 and a positive 0. There's just one 0. So there's only one equation. Move the 5 over, making 2x equals 5, just by adding 5. And then x is going to equal to 5 halves, because we divide by 2, divide by 2. So what we've basically said is 5 halves, which, as you know, is 2.5, or I guess is exactly equal to 2.5. So if you were to go in the number line here, let's just erase this one since we don't need this anymore. 2.5 is basically right there, and there's only one value that works. So if you put 5 halves in here, 2 times 5 halves, the 2's will cancel, you get 5 minus 5, which is 0. Take its absolute value, you'll get 0. There's only one number that works. Absolute value usually gives you two answers, but when the number on the right-hand side of the equal is actually 0, then you only have one answer. And that's why I wanted to do this one, to kind of show you that. All right, we have one more problem to do, just to increase the complexity just a little bit. What if we had the absolute value of 2x minus 1, absolute value closed, plus 3 greater than equal to 8. Greater than equal to 8. So this is a little bit weird because we have a number outside of the absolute value. We haven't seen that before. But still, you have an absolute value on one side of the inequality and a greater than sign. So before you go any farther, I want you to, in your mind, try to think what it's going to look like. And we can go back to the beginning to refresh your memory. When we had an absolute value greater than a number, then it ended up being an OR, and it looked like this. When we had an absolute value less than a number, it ended up looking like a segment like this, which was an AND. Now we have an absolute value greater than a number, which means if you were to kind of just think about it on the number line, whatever's on the left-hand side of the equal sign with the absolute, the inequality inside of the inequality here, is got to be greater than 8 units away. So if this is 0 and this is 8 and this is negative 8, what we're saying is that whatever's in this inequality, yes, there's a 3 here, I know, but just ignore it for now. It has to be bigger than 8 units away. So that means it's going to be way over here. This is bigger than 8 units away, and this is bigger than 8 units away in the negative direction. So what does this look like, an AND or an OR? It's an OR, just like we've been doing all the time. When it goes to plus and minus infinity like that, it's going to be an OR. And the reason I want you to know that is because the next step here is to translate this thing into that. But before we do that, we can still move the 3 over and just deal with the absolute value later. So what we have is 2x minus 1 greater than or equal to, subtract 3, which gives me 5. Minus 3 here gives me 0, minus 3 here gives me 5. And now, I mean, I could have done it another way. I could have ignored this and I could have said, just move the 3 over first and I can make this guy 5, negative 5, and positive 5. The point is, it's an OR type of situation because it's got to be greater than, this is going to be greater than 5 distance units away. So now we have to write the two inequalities that make that happen. It's going to be 2x minus 1 has to be greater than or equal to positive 5. That's going to be greater than 5 distance units over here, or 2x minus 1 has got to be less than or equal to negative 5 to give me all the distance units in the negative direction. This quantity has to be even more negative to be farther than 5 distance units in the negative direction. Okay? So now, we solve both equations separately, or both inequalities separately. We take the 1 and move it over here by adding 1, making 6. And then we just divide by 2, which gives me 3. So we have x greater than or equal to 3. Now we do the same thing. We add 1. When we add 1 here, we get negative 4. And then we divide by 2. So we have x here. We divide by 2. We get rid of it. We divide by 2. We get negative 2 here. And these are joined by an OR. So we're saying that x has to be greater than or equal to 3, or x has to be less than or equal to negative 2. So let's plot those and see what they look like. Greater than or equal to 3. So that means a closed circle. Greater than or equal to 3, like this. Or less than or equal to negative 2. Less than or equal to negative 2. Closed circle. Less than or equal to negative 2 means it goes this way. So what we're saying is that we have a segmented region that goes to plus infinity here, and we have a negative infinity over here, which looks like an OR type of situation, which makes total sense. So then you would circle this guy. So which parts of the number line are out of bounds? Anything in between here is not in the solution. So let's just pick one. Let's pick 0. Let's pick x is equal to 0. We're saying that it doesn't fit, right? If x is equal to 0, that's not bigger than 3. And x is 0 is not less than -2. So that makes sense. And if you put 0 in here, 2 times 0 is 0, minus 1. So you have -1 inside. But if you take the absolute value of that, you get +1. But then you add that to 3 and you get 4. But 4 is not greater than or equal to 8. So that shows you that the number 0 we picked, which we don't believe is in our solution set, it doesn't work, because when you put 0 in here, it doesn't satisfy this. Whereas if we pick, let's pick another value, like we believe 10 works because it's over here. We think 10 works. So we put 10 in here. 2 times 10 is 20, minus 1 is 19, right? And 19 plus 3, 20, 21, 22. So that's 22. That is greater than or equal to 8. So it does satisfy it. So the way we do this guy here is we get the absolute value portion. We have to kind of know roughly what they're going to look like to decide if they're and or. We can make a little sketch if we want to, but we have to ultimately write 2 inequalities and solve them and then plot them. So we're going to get more practice with this, but it's all going to come down to, for all of these problems, if you need to play this lesson again or sketch it yourself, do it, please, because understanding these 2 different cases is the most important thing in this lesson. This means that the values of x have to be more than 3 units away from 0. That means they have to be either bigger than 3 or less than -3, going both directions to positive and negative infinity. When we have this, we say that the x values have to be less than 2 distance units away from the origin. That means they have to be less than 2, but also greater than -2 in this bound up this region here. Notice that this is 2 distance units away, this is 2 distance units away. So the values of x are going to be somewhere in between less than 2 distance units away there. That's why it forms a segment. So one forms an or, this one, and one forms an and, which is this one. Follow me on to the next lesson. We'll get some more practice with this, and we'll be solving these types of absolute values inequalities in algebra. Learn anything at mathandscience.com.